Hello and welcome to another chemistry video. This is a question from an AQA paper from June 13 and it's Unit 4, and it's quite an old paper. It's nearly 7 years old now, but kinetics doesn't change, so I think it might be beneficial to go through this and try and clear up this topic which comes under kinetics. They've asked us, we've got a table of results here from some experiments, and they've asked us to calculate the order of reaction with respect to E. Well, let's look at experiments 1 and 2. Now, the reason I've chosen those is because that is 3 times that, and F doesn't change going from experiments 1 to 2. That goes up by 3. That goes up, no change. So if it was 0 order with respect to with respect to E, this wouldn't change. So it's not 0 order with respect to E. If it was first order, this would go up by 3. Well, it's not. You can check with your calculator that it hasn't gone up by 3. It's actually gone up by 9. Now 3 squared is 9. So that means it must be second order with respect to E. Hopefully that's straightforward. If that hadn't gone up at all, it'd be 0 order. If it had gone up by 3, it'd be first order, but it's gone up by 9. So I'm going to clear that away so that we can see the next bit. So we looked at experiments 1 and 2 to find out what the order is with respect to E, because F doesn't change. So let's get rid of that. We've also got to find the order of reaction with respect to F. So I would suggest we look at experiments 2 and 3. You could do 1 and 3, but it doesn't matter. We'll do 2 and 3. So going from experiment 2 to experiment 3, you have multiplied it by 2, the concentration of E. And we've done times a half. But this has gone down by a half, hasn't it? So we do times 0.5. Now, if you times this by, we're going to have to square this, aren't we? Because it's first order with respect to E. So you'd have to multiply that by 4 to take account of what we've done to E. Because it's second order and we've doubled it, it would go up by 4. Well, let's assume that it's first order with respect to F, because I think you can see that that rate is not 4 times that rate. That's not 4 times that. It's about double, isn't it? Yeah, it is double. So if we assume that it's first order with respect to F, it's obviously not 0 order. Let's try multiplying it by 0.5. So if you multiply 3.78 times 10 to the minus 3 by 4, and then by 0.5, and it's first order with respect to F, we're only guessing that it is, you should get this, the new rate, times 4 because second order, times 0.5 because it's first order. If you put that into the calculator, you should get that. So what we've done there, we've found out the order with respect to E, and we've found it with respect to F. There is a little bit left to this question, so I'm just going to pause for a moment and reset things. Okay, well, this is the second part of this question, and we need to use the data from experiment 4 because that's complete to work out the rate constant Okay, so this is the second part of that question, just a little bit of extra. They've asked us to calculate the rate constant from a different table, so you can forget about the previous table. This is a new one. And they've asked us to use experiment 4 to calculate the rate constant. So all I've done is I've rearranged this to give K equals rate over G squared for experiment 4 times H for experiment 4. And I put the numbers in. Hopefully I put the correct numbers in. So there's G squared because it's second order. There's H not squared because it's first order, as we can tell from the rate equation. So if you could put those into your calculator, you will get a value that we can use later, or that you can use later, because I'm not going to do the whole calculation, but I will do the units. Now, the units of the rate constant. Well, you need to know what the units of rate are. So on the top, we've got the units of rate, which is moles per decimeter cubed per second. And on the bottom, we've got concentration squared. Now, concentration is just moles per decimeter cubed, but it's squared. So what it's going to be is moles squared decimeters to the -6. That's just for this bit. This isn't squared, so that's just moles per decimeters cubed. Here we can do a bit of cancelling. We can cancel that moles per decimeter cubed with that one. Do not cancel the seconds because there's no seconds down here. But we don't want an equation, we don't want a fraction. We want to get this upstairs. We want to get it on the top. All you do is change the signs of these things. So what the units end up as being are seconds to the -1 is going to be there. But you change the sign of that, that's moles to the -2. And that'll be +6. And then you can use this rate constant in here to find the rate and fill that in. Hope this was helpful, and I hope to see you in the next one.